Hello, welcome all to the fourth edition of India March for Science, the webinar series. I'm Dr. Jyotsana and I would be the moderator for this webinar, which is on the topic Relevance of Basic Sciences. On the occasion of fourth edition of India March for Science, we are bringing a week-long webinar series on various scientific issues which are relevant for the time. India March for Science is the Indian version of Global March for Science movement. It reflects the aspiration of scientists, researchers, science-loving people of the country for greater support for science education and scientific research. India March for Science 2020 is dedicated to all the frontline workers and science workers in the service of science and humanity. So we welcome you all to this webinar, which is on the topic of relevance of basic sciences. So on this topic, I remember a quotation by 200-year-old quotation by a German physicist and philosopher, Christoph Lichtenberg, who wrote in his diary during 1782 when Pluto planet was discovered. He wrote that to invent an infallible remedy against toothache, which would take it away in a moment, might be as valuable and more than to discover a new planet. And he implicitly raised few questions like the relative importance of looking for technical solutions to specific problems and for searching for new fundamental research. So after 200 years now, the same questions are still pertinent today. So on this note, we would like to discuss the importance of basic sciences in the development of a country, of a nation, or as a humanity as a whole. Today we have a discussion, and for this we have amongst us Dr. Sarbari Bhattacharya. She is a physicist from Indian Institute of Technology, Chennai. She did her PhD on magnetic properties of the transition metal based on amorphous alloys from Tata Institute of Fundamental Research. And during her postdoctoral work at Laboratoire Optique at Magnétisme at University of Versailles, France, and at the Thin Films Division of Materials Research Laboratory, Technical University Darmstadt, Germany, she studied the effects of surfaces on the magnetic properties of materials. She joined the Department of Physics, Bangalore University, Bangalore, in 2007, where she is currently serving as assistant professor. In addition to teaching students who are pursuing master's degree in physics, as well as first-year students in engineering discipline, she pursues research on soft and living matter. So before starting this webinar, let me brief you on the format of today's discussion. Dr. Sarbari would discuss the topic first for about 40 minutes, followed by question and answer round. And if you have any queries during the talk, you can post your queries on the chat box or comment section so that we can ask on your behalf. And also, since we are depending on technology sitting at our homes, so in case any technical error or issue happens during the seminar, we request you to bear with us. We would try to rectify it as soon as possible. So on that note, I would like to request Dr. Sarbari to address us and start the discussion. Yeah. Over to you now.
So thank you, Jyotsana. Very nice, kind introduction. So if I can just go ahead and share my screen. Yeah, so I hope this is kind of visible. Yes. I'll just go to full screen mode. Yeah. So is this visible?
Yes.
Okay, thank you so much. Am I audible as well?
Yes.
Okay, great. Thank you so much. So I would like to start off, first of all, by thanking the people who have been at the organization helm of this week to commemorate the India March for Science occasion, which is a wonderful occasion in itself. There have been excellent webinars. There have been wonderful panel discussions. And I think I'm hoping that we can keep this up in the years to come because it has been a wonderful occasion and I'm very happy to be part of it. Secondly, I would like to actually join everybody in doffing my hat. The hat may be a virtual one, but the sentiment is absolutely genuine and very heartfelt of thanking all the workers who have been at the front line of this terrible health situation that we are facing at this moment. I will now go on to sharing my perception, it has to be my own, I guess, and views on the relevance of basic sciences. And what I will try and do is also cast this, which is actually a global issue, it's a pan world issue. I will also try to cast it in the Indian context. So, what I'm starting off with is essentially some figures, which some of which are my favorite actually, in the basic sciences as we kind of categorize them, kind of casting away a few other natural sciences, which is essentially physics, chemistry, and biology. And as you can see to your left-hand side, there is the Newton's cradle, one of my most, something I'm completely fascinated with, as well as that of a tardigrade, which again I find to be an extremely fascinating creature. So let's just move on. And the first thing I'll start off with is, if in the modern world, all of us, the first thing we do is essentially Google something that, we are curious about. So if you actually try and find out the definition of science, this is what will come up in Google. And they define it, it is defined rather, as the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. Now, trying to just distill this out into its very meaning, I would say it is a systematic approach of trying to understand how the world around us operates. And this, I would mean the physical and the natural world. And obviously, when we are trying to understand it, it has to happen through observation of phenomena around us, and then experiments which test our understanding of that observation. And then, of course, one goes ahead and makes a construct, a theoretical idea of how it must be working. Now, of course, that theory is not cast in iron or cast in something which is never destroyable. We need to test that theory further. And herein comes in the scientific method, the scientific mode of working, where we test that theory repeatedly. And only if it stands up to the various tests over time, it continues. Otherwise, the theory or the construct goes where it belongs, which is to the garbage bin. And a new construct is developed. Now, while we understand how, science works, or the scientific method works, the question that one can ask now is that why would anybody want to pursue science? What are the motivating factors of doing science? And in this, I would say there are three main reasons. The first, of course, is curiosity. How does the world operate the way it does? What are the reasons behind certain things, happening the way they are? So it is curiosity that drives us to do science. Now, the curiosity, of course, will help us do observation, experiment, come up with a construct. And what does the construct help us do? It helps us actually predict things which will happen. Now, the ability to predict things now could become a motivating factor for doing science. Now, prediction then goes to the next stage, that if you can predict, perhaps you can also control. And control is then an important factor or a motivating factor for doing the sciences. Now, what we will be talking about here on is essentially what we call as the basic sciences and what we call as the applied sciences. And what we realize is the measure to which these three motivating factors appear in those sciences actually vary. So let me just go on. And here I'm going to now start off with talking about basic sciences. Now, again, go to Google or go to Wikipedia and find out what basic sciences are formally defined as. So it says that it establishes and develops information that firstly helps us understand nature and secondly predict phenomena. Now, the point is that, as you realize, that curiosity and the ability to predict are the motivating factors behind doing basic sciences. Now, when I kind of looked at the formal definition, something which I don't usually do, I found that basic sciences is an idea which are strongly associated with what are defined as natural sciences. Now, what are natural sciences? These are essentially the description, prediction, and understanding of natural phenomena. And this is once again based on an empirical evidence which is gathered from both observation and experimentation. Now, basic sciences itself can be categorized into the life sciences and the physical sciences. So, the life sciences would be essentially biology with all its branches, and physical sciences could be divided into physics, chemistry, earth sciences, and astronomy. Now, what I have put over here are some of my really favorite images. You have over here a Thomson's gazelle, which is actually an extremely high life form, and it is a pretty complicated thing to understand, definitely from the point of view of a physicist, which is my own training. You have physics, and to me, this particular figure, which is of refraction and the pencil-looking bend, has always been a source of incredible amount of fascination, despite the fact that I do understand how it works. You also have an image from the earth sciences, which is that of a majestic volcano, and structure of molecules. Fascinating, how you actually can end up interrogating a material and coming up with a structure for it. And of course, something which I think a lot of us will confess has actually drawn us perhaps to doing physics, amongst the physicists at least, and definitely a lot of people to even science, is why the questions we ask about the structures we see in the sky. So here you can see the picture of the Milky Way, again, a source of endless fascination for mankind. Now, let us go on to the other branch, other in the sense of basic science, and then we go to applied science. And what applied science does is essentially it uses portions of basic science. It's not really interested in everything. It uses those portions of basic science to develop technology and techniques. Now, what is this technology and techniques used for? The idea is to basically alter events or outcomes. So herein comes in the, I would say, mostly the motivation, not just from curiosity, but also the ability to predict and thereby control. So now you basically have a construct which tells you how to predict things, and then you develop means of controlling the outcome. You realize that if you tweak something, you essentially get an outcome which you want. And thereby, applied science essentially is the translation from prediction to control. Of course, there is curiosity, without which nothing would actually move, but it is the emphasis is more on the second and the third reasons I have put in as why somebody pursues science. Now, if you look at the branches of applied science in something like Wikipedia, it's an astounding number. What I have picked up is 2, and this is because these are actually touted as career choices for students who go in for the science stream post their 10th standard. Up till 10th, every subject is taught with the same amount of emphasis. In our country, in the education system that is there right now, we are headed for changes, I know, but in the education system that is in place right now, we put equal emphasis on all subjects till the 10th. And in 11th and 12th, there is a specialization, or in the first PU, in the PU, there is a specialization. And students who go in for science, essentially, these are touted as suitable career choices. So one is engineering. And in engineering, what does one do? The basic idea is that you try to improve the lives of people. And how you do it is that you use some amount of basic science, and then you design and build things. And what could these things be? They can be structures, they can be machines, they can be devices. You could actually design a system, you could design new materials or processes, and all of these are meant to improve the lives of people. Now, the key factor over here is that you have to do it in a safe manner. And the point is, what I realized when I was trying to, run over this definition myself in my head, that safe is what you can foresee, from the point of view. We do realize that certain engineering aspects have actually in the long run turned out to be rather harmful practices. But the point is that when an engineering feat is put into practice, one cannot see beyond a certain number of years, and that's something we should keep in mind. The other, of course, is medicine, which is essentially the science of healing. Now, the images that I picked up over here have been done on purpose because, as you can see, the central image that we have over here is an MRI machine. Okay, so magnetic resonance imaging. Now, we do realize that the origins of this would have happened in physics, where the idea of magnetic resonance itself would have come up. It would have required engineers to have built a machine like this. And today, it is a very important component of trying to find out what is medically wrong with a person. Similarly, you can see the image which is on the rightmost extreme at the bottom row, which are essentially X-rays. So X-rays, of course, were discovered by Röntgen. And here we see a medically useful representation of it. An X-ray machine, of course, again, which could be used safely for medical purposes, would have been designed by engineers. What we have on the leftmost extreme over here is a communication satellite. We are able to do things on this digital platform because we are having communication satellites. And not only that, this is something you can call it an absolute marvel of an engineering. I mean, it's an engineering feat, in fact. And satellites themselves now can further the aims of basic sciences. So engineering could actually try and further the base of basic sciences. So you could actually be doing, studies of the sky from a satellite. You could be actually figuring out how living organisms, work under the conditions of lesser gravity or free fall. So moving on to this question now, as to the relevance of basic sciences. Now, when we talk about relevance of basic sciences, let me move to the other extreme and ask the question is that when do we deem something irrelevant? Now, something, in my opinion, becomes irrelevant when it is, one, obsolete knowledge, or two, when it has actually been proved wrong. Now, I have picked up two examples. They need not be from basic sciences per se, but I have picked up two examples to kind of illustrate what I mean by these. Now, what you see on the right-hand side over here is a collection of stones, and these are actually flint stones. Now, flint stones are a form of the mineral quartz. And when we say flint stones, the first, I think, association that we have in our minds is that it can be used to produce fire. So what is the way in which it works? Now, please remember, flintstone is something that flakes easily. It can leave sharp edges, and our ancestors actually used them for making tools. They actually could then put it through a process of hardening, which basically kept the edge the way they liked it. And it could be used for cutting, for hunting. Now, the point is that when flint is struck against steel, it actually exposes some iron. And then I think there is an oxidation process which happens, which is highly exothermic, producing sparks. Now, of course, those sparks need to set up on some highly combustible material, which you would refer to as tinder. That tinder, because it's highly combustible, perhaps that fire doesn't last long. You use to set fire to something which you call as kindling, which are small twigs and branches. And then that can be used to set up fire to a bulk material like, let's say, logs of wood. Now, prior to the availability of steel, flint was actually struck against rocks of pyrite, which were essentially FeS2, to set up fires. Now, while the science behind the setting up of fire using flintstones is definitely as, there's nothing that has been proved wrong about it, we can well imagine that this knowledge, apart from esoteric reasons, and for some people who actually would like to, keep this knowledge intact and, learn how to do it themselves. And there are videos on YouTube which are available to show you how it is actually done, I can imagine that most of us will go through our lifetime without actually requiring to use that knowledge. Now, the point is thereby for survival, what was once, absolutely imperative, perhaps people would perish because they didn't know how to start a fire. Now we have come to a stage where even if you have never heard of Flintstones, you will do perfectly fine. You may even do extremely well in your life without knowing about Flintstones. So it is in some sense obsolete knowledge. The second thing that I've picked up is alchemy. And alchemy, we all know, is the medieval forerunner of the modern day chemistry. And what did alchemy actually work on? Now, this is an idea which actually went across the globe practically. So Asia, Europe, North Africa. And the basic idea was that there are these 5 elements, which is air, earth, fire, water, and ether, which we also sometimes refer to as the sky. And essentially, the idea was to do things like transmutation of base metals to noble metals, the creation of an elixir of immortality, panaceas which could cure any disease, the search for an universal solvent. And while we know that a lot of those techniques and the efforts put in by alchemists have led to the understanding of chemistry today, the truth is that a lot of those things have actually been also proved wrong. Now, interestingly, in my read up on alchemy, I found that this particular thing, the Philosopher's Stone, was actually something that was heavily researched for, okay, in whatever researched protocols that were set up in those days. And one of the key persons who was actually associated with this was a alchemist by the name of Nicholas Flamel. And those of us who read Harry Potter would actually remember the reference to Nicholas Flamel and the Philosopher's Stone. So Philosopher's Stone is supposed to grant the person who uses it, I don't know how, eternal life. Okay. So alchemy, as I say, has been proved, good parts of it have been actually proved wrong. So now the question is that if we are talking about relevance of basic sciences, which of this is? Is it being proved wrong? And that's definitely not true. And the second thing is that, is it obsolete? I mean, have we developed to the extent that we can only work on the applications and forget about the basic sciences per se? And definitely that is also not true. And that I will exemplify by showing you 2 examples. So one, as a physicist, of course, has to be a physics example. I'm sorry, my apologies. I could have picked up a whole bunch of examples, but these are something which I thought we will find relevant. Now, I start off with something which is called as magnetoresistance. Now, let me just clarify. Resistance is something to do with electrical circuits. Some of us may remember this. For those who don't, let me just tell you. Resistance essentially is some kind of a impeding of the flow of current. Okay, so when current wants to flow through a material, there is a kind of a resistance to the flow, and that is what we call as electroresistance. Now, there's a way of measuring it. Of course, you apply a potential difference as a current flowing through, and the relative the proportionality between them has to do something with the resistance of the material. Now, when I say magnetoresistance, you basically imagine that the resistance is being measured as is, and then you apply a magnetic field and you measure the resistance. And if there is a difference, then you say that the material shows a magnetoresistance. And there is a way in which you can put in a number for that. This is the resistance in the presence of the magnetic field. This is the resistance as such. And you can actually show this as a percentage. Now, you can well imagine that only somebody who is very curious about what happens to the resistance when a magnetic field is also present, okay, would have actually carried out such an experiment. So when I say giant magnetoresistance, it is basically a magnetoresistance which is much more than what is expected. Okay, so let's just go with that. Now, this was a phenomena that was discovered by these 2 guys independently. One is Albert Ferret, who was from the University Paris-Sud in France. Sorry about that. I'll get back to my slide again. And the other guy was Peter Grunberg, and he was from the Forschungszentrum at Jülich in Germany. And these guys found it out in 1988. Albert Fert actually did it at very low temperatures. He saw a huge difference of 50%. Peter Grunberg did it at room temperature, and he found a difference of only 3%. Okay. But the basic material that they worked on was, they had constructed it maybe on a lark. And what did it consist of? It was a multi-layer material. One of the set of layers was essentially a ferromagnet. The other layer, they were interspersed by layers of non-magnetic materials, but in this particular case, they were also conducting. And what they found was that when the ferromagnetic layers were oppositely aligned, there was a very high resistance to the flow of current, which completely changed when they brought in a magnet. All the ferromagnetic layers started aligning with each other, their magnetic moments, and the current, could just flow through. The resistance had dropped like crazy. So this technology, okay, so this was not technology at that point of time. This was basic science. This actually developed into the technology of the gigabyte hard disks, for which these two guys actually got the 2007 Nobel Prize. Now, allied topic. So there's something they developed which is called as a spin valve. Allied to that spin valve is what we have over here, which is called as a magnetic tunnel junction. Now, magnetic tunnel junction essentially has again two ferromagnetic layers, separated now by not only non-magnetic, but it is also an insulating layer. It is resistive to the flow of current. And what people found is that if these magnetic layers are again allied, then you can actually have a current which goes through. This is a totally quantum mechanical phenomena. It is called as tunneling. By rights, it's like throwing a ball through a wire, through a wall. Okay, so if you have a wall, you expect the ball to bounce back. But if it goes through on the other side, it is tunneling. And this is what is happening at this, I would say, this nanoscale. Okay, now this what essentially transformed this particular junction from, let's say, a low resistance state to a high resistance state. Okay, and what we can well imagine is that in computer technology, information is stored in the binary language, where all you need is two different symbols, one for a low state and one for a high state. And this actually would qualify. Again, done by somebody in 1975, somebody called Michel Huillier in the University of Rennes in France. And he basically did it again at low temperatures. He got a 14% change in the magnetoresistance. And, he did it because he just wanted to find out what happens when you apply a magnetic field and take resistance measurements. Now, this has developed into something which we call as the magnetoresistive random access memory. And this is a memory device which it does not require power to keep that memory there. Okay, so it is essentially non-volatile. You switch off the power, it's not that what you have stored, the information goes away, which is extremely important. It doesn't consume power when it's off. It is extremely high density. Each of these bits would be like 14 nanometers. To give you an idea, the hydrogen atom is probably, 1 angstrom across. So this is like few atomic diameters that we are talking about, each of these bits. It can do a very high speed operation, and you can keep doing read, erase, write, read, erase, write several times without actually reducing the capacity. So a fantastic kind of a memory device. And this MRAM, so now the question is, yes, it's there in the lab. Did it actually get translated into reality? And what I will say is that, yes, it did. In the sense, like this is something which I picked up from what is called as Patently Apple. In the Patently Extra News bit, this came out in 2000. Sorry, I think I've skipped several slides. It came out in the year 2017. And what you see over here is Samsung planning to mass produce the MRAM memories for mobile devices. Okay, now whether it has actually come into being, I don't know, because I think these companies guard their secrets extremely carefully. They don't want their competitors to know. And but the point is that the mobile devices that we are using, maybe our cell phone, maybe the tabs, maybe the laptop, could actually be working on this MRAM memories. So thereby, basic science leading to something that we cannot imagine our life without. Okay. Let's move on to a completely different example. And here I will come to the structure of the DNA. So let me confess that I'm stepping into territory which I'm not terribly comfortable with, but I'm absolutely fascinated with. So I would like to share my thoughts on this. Now, the structure of the DNA we know has been credited essentially to these guys. This is Francis Crick over here. This is James Watson, both of whom started off as basic science people who were just curious about the structure of the DNA, which had been first isolated by this guy, Friedrich Miescher, in 1869. Now, they were, of course, very ably assisted by the excellent X-ray diffractograms that were taken in King's College in London. These guys were from the Cavendish Laboratory in the University of Cambridge. And this lady, Rosalind Franklin, she was at the King's College in London. And she and Maurice Wilkins, who also got the Nobel along with these two guys, actually recorded X-ray diffractograms of the DNA. And it was one of her diffractograms, which was taken by Raymond Gosling, who was a postgraduate student with her, which actually helped these guys come up with their theoretical model of the DNA. And what you realize is that apparently the papers of Watson and Crick appeared in tandem with two more papers in Nature. That was one with Maurice Wilkins and the other with Rosalind Franklin. Watson and Crick giving the theoretical model, and Maurice Wilkins and Rosalind Franklin essentially presenting the experimental data on the DNA. And that's how basically one came to figure out the structure of the DNA. Now, Crick over here was actually a physicist by training before he turned biophysicist. And funnily enough, he actually was saved from a career in physics. He calls it an extremely boring project of actually measuring the viscosity of water at very high temperatures. And he was saved from doing that because a bomb, this was during the time of World War II, a bomb actually fell through the roof of the laboratory and destroyed his equipment. So this is why he got on to doing the structure of the DNA, luckily for us. Now, the point is that what they found in the DNA was, of course, that it's a double helix structure, which is what was very interesting. And there was a complementary base pairing. Okay, so there are these four, I think, nucleic acids which we talk about when we say DNA: adenine, thymine, guanine, and cytosine. And adenine always goes with thymine, guanine always with cytosine. So which means that even if you unzipped the DNA structure, you would essentially be able to figure out what really lies on the other strand. And as they said in their paper, with the typical British understatement, that it has not escaped our notice that the specific pairing we have postulated immediately suggests a possible copying mechanism for genetic material. Not only that, I think Rosalind Franklin herself had commented that she realized that this can lead to an infinite number of combinations, and thereby you could have very rich information which is actually put into this DNA structure. Now move on to the situation of pandemics, because this is on everybody's tongue these days. So I thought I will show you the connection between that DNA structure and the current situation that we are facing. So cut back to a century earlier, where we had what is called as the Spanish flu. A lot of people claim that it wasn't fair to call it the Spanish flu, but nonetheless, it is basically the 1918 flu pandemic. Now, this was caused by the H1N1 influenza A virus. It lasted for the period between almost 2 years, February 1918 to April 1920. It infected 500 million people. And that was about a third of the world's population at that time. And it happened in 4 successive waves. It's something that we should really feel scared about right now. The death toll was estimated to be somewhere between 17 million to 50 million. And it was the deadliest pandemic in human history, a record which we hope will remain unchallenged. Now, these are some of the shots that I have picked up from that period, and they are chilling reminders that we are perhaps going through the same thing today. However, there are certain extremely important differences, and that is where the basic science interest of Watson Crick, Rosalind Franklin, and Maurice Wilkins comes in. So here we are today, the coronavirus, perhaps dominating all our thoughts, except that you can see over here that we already have an idea of what is the causative agent. And what you see over here on the left-hand side top, on the right-hand side top, is essentially a false color transmission electron microscope image of the virus that is the causative agent. And it is these spikes which have given it the name of coronavirus. Of course, I do believe that this is not the only coronavirus. There are lots of coronavirus. This particular one is what is causing the current pandemic. Now, compared to those masks that we saw, these are some of the, I would say, the cutting edge masks that are being done up, which are both safe. They take on the shape of your face, and they are also extremely comfortable in the sense breathing ease, so that you can do your regular activities, which may be even sports activities, without really requiring to take off your mask. Hopefully, we will not need those. Going on to what is the manner of disease control. Now, here I'm really completely out of my depth, so I will beg forgiveness from all the experts whom I may be quoting wrong. But virus identification, even from the Center of Disease Control, they will tell you is key to the control of a disease. Now, some of this I have picked up actually in reference to the Nipah virus, but nonetheless, I think they would apply to a whole section of things. So here are put up some of the methods of actual virus identification. And one of them is, for instance, immunofluorescence of virus-infected cells. Then this reverse transcription polymerase chain reaction, which essentially catalyzes DNA synthesis using RNA as a template on extracts of cell supernatants using specific primers or probes. Let me get back. Yeah. Now, this is actually a very important method for us now, because if you look at the COVID-19 information pages, what you realize is that this is a standard method of diagnosis, and it's done there's a real-time RT-PCR which is being done. And this is done on the samples which have been picked up from this, what is called as nasopharyngeal swab, which we know is either a nose or a pharynx swab, okay, which the sample is taken, which I have shown over here and here. The sample is taken, and then it is subjected to this real-time NT-PCR, NRT-PCR, and then we essentially figure out whether the person is a carrier or not. Now, there is, of course, something called as a Tachman assay, which again figures out the virus genome. And the virus genome I hear is either DNA or RNA, but never both. Now, what one realizes is the detection of the virus is definitely, I may be not giving enough credit to the people who have developed the protocols and brought this a long way, but I do believe that some bit of it is owed to the structure of the DNA, which was triggered by people just being curious about the DNA structure. Now, here we come to a vaccine, which seems to be our great hope. Vaccine, of course, is a biological preparation that provides active acquired immunity to a particular infectious disease. And what happens is that when a person is basically, the person is given the vaccine, the body's immune system essentially recognizes the agent as a threat. It destroys it. Not only that, it then has within it antibodies, which will then destroy any microorganism which recognizes that initial threat. Okay, which means that you become essentially immune to that disease. Now, vaccines contain an agent which resemble the disease-causing microorganism, but they are either inactivated, attenuated, they are toxoids, they could be subunits. Now, subunits, again, I would like to mention the case of hepatitis B, where the subunit which is used is the surface proteins of the virus. And initially, they were actually taken from the blood serum of chronically infected patients. But now, you can actually do that by recombining the viral genes into yeast, okay, and produce it in a lab. So, again, thanks to knowing in some way to knowing the structure of the DNA. There are also experimental vaccines which are there. One which involves actually injecting the DNA into the cells of a healthy person. The other actually is a recombinant vector where a microorganism is taken and the DNA of the infecting agent is taken, and you create a new life form which can be actually used as a vaccine. And I do believe that trials of this to fight against Ebola are underway. So, again, basic sciences being our, at least the foundation of our hope today to fight against this particular disease. Now, cut to the situation in India. Okay, so I'm now going to talk about relevance of basic sciences in India. At the research level, I hope we have no more doubts left. But let us now talk about basic science education. So here I have just pulled out some report which tries to tell you the percentage of children going to school in India in urban and rural settings. And what you realize that at least in the age group of 6 to 10, practically every kid attends some form of schooling. It could be a government school, a private school, something like run by an organization like a madrasa, but they do attend some form of schooling, which of course, unfortunately, drops off very rapidly as they head towards the age group of 17, and unfortunately, very heavily in the case of girls. Now, the point is, why do we care about basic science education in schools? Now, let us think about children in a rural setting, sometimes even in urban settings. I would talk about rural settings more because the exposure to outside elements is slightly restricted there. There are less choices for entertainment, let's face it. So the influence of the family, the influence of the community is extremely strong, and all the beliefs of the community and the family are put on the children. And here I would like to talk about certain superstitions and blind beliefs that people tend to believe. Now, for instance, I have listed over here a whole bunch of these which are sometimes silly and very mostly harmless. We shall not take it beyond the immediate consequence of what happens if you follow that superstition. And there are things like, you ward off evil with lemon and chilies, do not venture under a peepal tree after sunset. People will give you scientific reasons for this, but I don't think those were the, at least they have become obsolete knowledge in my opinion. Not cutting nails and hair after sunset, eating curd before you step out of the house to accomplish a task. As you see over here, this cute little child who's been, put a black dot on the face to ward off the evil eye. There are meanings that are associated if you have an itchy palm or you are eye twitches. I think for male and female, left and right eye have different significances. Women, sadly, this is a very sad thing, are not allowed into the temple and certain parts of the house even during menstruation. There are fear of black cats crossing your path. People would actually, wait some time, or they would take a different path, or even of upside down slippers. Now, these, while they are essentially, they could be silly, but they are essentially harmless. There are others which are actually extremely harmful. And here you can see a recent paper, not very recent, but it's 2018, where people have talked about myths and superstition about epilepsy. And this is a study from the north of India. Now, just because it's from the north of India doesn't mean that these practices are not prevalent in the south. I'm sure they are. And what is shocking is that this doesn't seem to correlate terribly with urban or rural settings. There are a lot of misconceptions about this disease, epilepsy, which unfortunately is a fairly common disease. Now, I have just shown the methods that they have used in conclusions, and it's available for free download. People who are interested can go ahead and read it. And what they say is that In the survey conducted by a team, we come to the truth that urban population do consider epilepsy as an unnatural phenomena and adopt different treatment tactics. And they have listed a whole bunch of tactics, some of which I'm going to talk about. And there is an urgent need for creating awareness amongst the common people. Okay, and it has to happen through newspaper, television, health camps, training local health practitioners, and so on and so forth. So let's just try and distill that information. And this is also from a newspaper article which came out in 2018 in the Hindu on the occasion of the World Epilepsy Day. They say that the doctors have said that epilepsy patients actually face a lot of stigma and discrimination. And why is that stigma and discrimination there? It's because they believe that the person is possessed with evil spirits, and this has happened because of a punishment from the gods, or the person is being punished by the gods, leave alone the evil spirit. But whatever it is a reason for people to feel ashamed, which means that they try to hide the disease, they do not talk or seek help, and as a result, they tend to go to the traditional methods of trying to get rid of this rather than approach modern medicine practitioners. So to ward off the evil spirit, some of which may be not so harmful, but there are others which are downright harmful. What they do is sometimes make the person wear bangles of different metals. In fact, I am myself witness to a person having an epileptic stroke and somebody pushing an iron key into that person's hand. I've seen this myself. The second thing is really bad, which is like they are made to undergo painful procedures like branding with hot iron objects and pointed metal and glass objects. Some even follow practices like tattooing, burning with leather objects. And of course, amulets and, sacred threads are worn to ward off the evil spirits. Now, you realize that there is a heavy need for rational and scientific thought over here to get rid of this. This is another thing which I would like to talk about. And here, basically, the uses of cow urine, which is actually being presented as a panacea, what the alchemists were searching for. So if you look at the thought about, possible benefits of cow urine, especially that of a pregnant cow, you can see that it's touted to cure leprosy, fever, peptic ulcers, liver ailments, kidney disorders, asthma, allergies, psoriasis, anemia, and even cancer. Now, unfortunately, I would say that India is not the only country which actually believes in such things. This is heavily used in Myanmar and Nigeria as a folk medicine. And in fact, in Nigeria, a concoction of cow urine with tobacco, garlic, lemon basil juice, rock salt has been used to treat convulsions in children, and sadly enough resulted in death of several children from respiratory depression. So what's the way out? And what I believe is that the hope is that a training in the basic sciences will at least set up a core of rational thought and reasoning that can guide a child as she grows into an adult. So she may take the beliefs of the community, but if she has a rational core that has been developed from a basic science training, she is likely to ask a few questions. And what that can do is it can help in resisting the milieu of blind belief and superstition that is thrust on a child, so that even if the child grows up partially, conforming to those thoughts, she or he will hesitate to translate it onto the next generation. So let's face it, there are no instant solutions to this. However, a strong training in scientific thought for the young, a development of scientific temper in the basic, and thereby a strong base in the basic sciences are our only way out of the darkness. Now, I would like to conclude now, and I'm going to talk about this particular thing, Choluteca Bridge. Now, a lot of you, I think, have been flooded by this on the WhatsApp. So please forgive me if I'm boring you once again, but I would like to put it in the context of the relevance of basic sciences. So this is actually the old Choluteca Bridge, the image that you see over here, also called the Puente de Choluteca, Apologies to those who speak Spanish. I may not have pronounced it correctly. This is in the country of Honduras. It's at the city of Choluteca, also on the Choluteca River, sorry. This bridge is about 384 meters long, and it's very much functional today. However, in the 1990s, what the Honduran government wanted was a new bypass road, and there was a new bridge that was planned for the city. And this bridge was given the name as the Bridge of the Rising Sun. And this was actually, the contract was given to a Japanese company called Hazama Ando Corporation. And the idea was that despite the violent weather and weather changes that this region saw, they wanted a bridge which would last. Okay. And the Hazama Ando Corporation actually built it between 1996 and 1998. This bridge was 484 meters long. The Choluteca River, which flowed under it, was about 300 meters below it, across span. And this was actually the largest bridge that was constructed by a Japanese company in Latin America. Now, in the same year that the bridge was commissioned for use, Honduras was actually hit by Hurricane Mitch. Now, a very sad beginning, I would say, but the bridge survived. This Bridge of the Rising Sun actually survived. A lot of things got destroyed, including the old Choluteca Bridge the construction was fairly damaged, but this new bridge passed through this test of fire. However, sadly enough, the road that led up to the bridge was swept away. The road that led away from the bridge was swept away. And the river, what happened was the whole place got flooded. And when the flood receded, people found that the Choluteca River had carved out a new path for itself, and now it flowed beside the bridge. So this is essentially the image. You can see the bridge over here, and there is your Choluteca River flowing beside the bridge. Now, what is the context in which I am bringing this up? What I'm trying to say is that basic science research today, we may not be able to envisage any immediate uses. But just like I showed you in the MRAM, or just like I showed you need of the hour, a vaccine against COVID-19, okay? These have all had some thanks to pure curiosity in the lab and a systematic method of pursuing the answers to satisfy that curiosity. So basic science research today can be the foundation of cutting edge technology tomorrow. So thereby, we can ask the question, why don't we just concentrate on the research, on the cutting edge technology, and when basic science is required, we can pick it up. That is not going to happen because you need trained manpower. You need fantastic labs. This has to be a tradition and it has to be an ongoing activity. So the point is a sound training in the basic sciences, a robust research tradition, an establishment of good research labs in the basic sciences. Only these can give us a chance to adapt and survive when things change in a manner we cannot even imagine. So when you see this bridge, which is a feat of engineering, it's a marvel of engineering. It survived a catastrophe. It stayed intact when everything around it was destroyed. However, it could not account for the fact that the river itself may change. So if you try to build on the foundations which brings up such a kind of thing, you will not be able to find the ways and means to adapt when things change beyond imagination. In that case, you need to go back to the basic training and look for a new solution. If that basic training goes missing, I'm afraid we will all run the risk of being rendered redundant, just like this bridge. So with that, I will thank you all for your time and attention, and I am willing to take questions now.
Thank you, Dr. Sarbari. It was really an insightful talk, and you nicely explained the relationship between basic sciences and applied sciences, giving nice examples. So because we are running out of time, I apologize for not taking all the questions. But whatever questions I have come across from our audience, mainly funding issue had come up. So can you explain, as one of the viewers has asked, like in government schools in rural areas, we lack such infrastructures for performing experiments, hands-on science experiments. And in
Right.
COVID times, the whole country is deprived of science experiments or labs. So how
True.
to combat this problem, and how about a startup that could take science labs on wheels to children and help them learn? So your thoughts on that?
Yeah. So, what I would say is that this is absolutely true that even in the best funded schools in the country, we are facing this problem that in the times of COVID-19, children are unable to access labs. Now, I only can say that labs have to happen hands on. So, if the schools can make a arrangement that a few of the kids land up in a lab at a time, of course, it is going to require a lot of time on the part of the teacher, and a lot of people have to overcome their fear of even sending their kid to school for a single day. But perhaps if it can be done in small numbers, it could be managed. Now the question comes to those schools which actually don't even have the infrastructure. Now unfortunately, I have been finding that laboratory practices in most schools have been actually diluted over the years. Even what I did in school, my kid is not doing in school. And I find that very alarming because it requires money and it requires effort. And, people finally doesn't translate to marks. So people are only looking in terms of marks. So I don't know how the new education policy is going to address that. But my request is to parents, please don't just ask for a reduction of fees from the school. Rather, put in that money and make sure the school runs a good lab. Because unless and until the end user demands things of a school, the school is going to divert the funding into making a very fancy looking office, beautiful classrooms, rather than actually putting the money into science labs. So I think as parents, we have to be aware and also demand that schools do something. And if the school demands a little bit of extra money, if it is within your capacity, put it in. This is for the private schools and urban schools. In the rural schools, I think we have to ensure that the government schools also have wonderful labs, mobile laboratories, if they can be set up by voluntary organizations, should also come up. People, NGOs, people who are interested in such things can volunteer to bring up mobile labs which go from place to place and demonstrate things to children, try and involve them. And we have seen how starved our country is of this. Open day in IISc, it's flooded, so people want it. So we have to give it to them. And I'm sure I've not come up with some great ideas, and I'm sure people have wonderful ideas, but we all need to think together in this direction.
Yeah. So next question I would like to ask is, why is industry academia partnership not effective in India?
I didn't get you. Just could you repeat the question? What
Yes.
partnership?
Industry academia partnership.
Yes. See, I think this is extremely sad because I think we could benefit hugely because I think all the manpower is there. Very often, I do believe that industries, the translation from something which is happening in a research lab to an industrial forefront, okay, doesn't really happen. That translation is extremely poor in India. And I have seen very sad examples where people have done wonderful things in a lab and it was ripe for industry, and somehow things were not conducive and it didn't happen, and people had to just give up that idea. There are examples galore, unfortunately. Now, and this is happening where essentially there is actually a materials cost involved rather than just a more hardware kind of a situation rather than a software. Now, I do believe that we have to ask the government to make things easier for people. See, very often what happens is the red tape kills people, and that I think we have to make sure that government policies, if we are responsible because we elect our government has to put in policies which can actually reduce the red tape for such things and make startups of hardware kind of situation, materials development, new devices, possible, rather than, I mean, if you think about even a plug point, you get plug points of different sizes. Very often you try to fit it into a standard, a plug into a standard plug point, and you find there's a mismatch. Why should this happen? So standardization of things is also extremely important. And this can happen. It's just that the right incentives have to be provided, and reduction of red tape and corruption, definitely.
Yeah, here comes the role of government, because applied sciences is backed up with economy, but basic sciences, we need funds from public sector. So that's where government's role is important.
True. So the point is that, there is always a demand that you show an immediate application. But what I'm saying is that, you cannot be so selfish that you say, hey, show it to me tomorrow, because the application may be waiting, 4 years down the line. And certain things you actually cannot think of applications, like, for instance, understanding stars around you. What immediate application can you think of that? But I'm sure that, the technology that develops to basically understand what is in the skies, those things have actually changed our lives, like enormously. I'm completely sure about that. And I'm sure there are examples abound. Right now, nothing is coming to mind, but there are examples.
Yeah, I think Dr. Sarbari, you need to mute your mic while I'm asking the questions.
I'll do
think, because that's why I'm echoing. Yeah, so there's one more question. Are there other reasons for the neglect of basic sciences that need, apart from the lack of an immediate commercial benefit, often which is cited? Is there any other reason you think that the neglect of basic sciences, apart from the commercial benefit?
See, I do believe that a lot of bright children, are not going in for the basic sciences. And very often, I think they do it because they are so motivated. They do it despite their parents kind of discouraging them. Because we do not see basic sciences as a good career option. So either it is left to people who are not able to get into, say, engineering or medicine, people even who have chosen science. I'm not talking about people who don't choose science. And as a result, I do believe that, while some of the brightest and best minds do stay, and definitely certain people are trained, to think in the right way. But the point is, I think there is, as far as basic sciences is concerned, a severe brain drain. And partially it is because of the lack of motivation that has done because of the kind of schooling that we have degraded into. And also because parents, and I completely sympathize with parents, please don't misunderstand me. I know you want the best for your child, and sometimes it is difficult for us to see an option like that working out in the basic sciences. But I frankly do not know a solution for that.
I think culture also plays a role in inculcating curiosity in a child, and making them curious about things around them. So I think culture also plays a big part in while bringing up a child, and culture of a society as a whole. So I think we need to change our mindsets. Like, are we giving the proper background information, or while raising a kid, we need to make them more curious about their surroundings. So I think throughout the society also, we need, as a citizen also, we need to change our mindsets, and bring up in children these such mindset.
I think I would agree with you. I mean, we should perhaps change the definition of a good child or an obedient child, in the sense of a child who basically does things without questioning. Now, when we are in the role of controlling, sometimes it may be nice to have your kid not argue back with you. But the truth is, it is important that the child asks why or how. And however annoying or irritating it may be, I think it is something that should be encouraged always. So when a child says, why should I do this? You should not say that this is, because I'm telling you to do it and you better listen to me. But you should encourage, that the rationale behind it. And I'm sure it will not work always, because, children can really try their parents, and sometimes they are just doing it to wind you up. But nonetheless, I think it is an important thing to basically inculcate in the child, that the child questions. And I think that is very important as far as basic sciences is concerned. So I completely agree with you.
So next question is, can you suggest few books that bring interest towards basic science, especially among students?
Yeah, this you would be talking at what age group? Actually, I mean, see, for instance, I have like looked through the NCRT textbooks, okay, and while I think they have diluted things quite heavily till a certain age, in the sense there's no segregation of the sciences, but some of them are actually very, very well written. Yeah, and so definitely I would recommend that, just go through the textbook with your child and explain things. And sometimes they are fairly well done, the NCRT textbooks themselves. Of course, this I'm talking about the textbooks which, when my kid was studying in those grades, I have looked at. Apart from that, I mean, I can, only perhaps my recollection goes back to physics books at the 11th and 12th grade and beyond. And definitely, I mean, Resnick and Halliday has been one of my favorites. So, physics wise, I would definitely recommend. There is this book by Zumdahl in chemistry. It's again a very exciting and nice book. But yeah, I mean, I should really think about this and write down answers
Yeah.
and perhaps put it up somewhere. Yeah.
Yeah, so thank you, Dr. Sarbari, for such a insightful talk and discussion. We are really grateful to have you here today. So I think most of the questions we have covered today, and I would like to thank Deepti for managing all the background technical issues, and you, of course, and all our viewers. So with that note, I think we are good to end the show today.
Yeah.
So
So
Deepti,
thank
is
you,
it
Jyotsna.
okay? Thank you, ma'am.
Thank you, and thank you for having me on. I mean, this was a very nice. The privilege was all
It
mine.
was,
Thank you.
yeah, it was pleasure for us also. Thank you.
Thank you.